Practice. Here, we're using left and right endpoints to approximate the area under the curve. We're not going to simplify the expression, okay? So using left-hand endpoints, what we're going to get is that the area approximately equals, well, I don't know. So we have n equals 3, and we're going to have that a to b equals, right, 0 to 6. So delta x is going to equal 6 minus 0 over 3, which is 2. And that works out pretty nicely, right? So always nice when we have a good rectangle width. It's not always so nice, right? So anyway, left-hand endpoints, we're going to be starting at 0, 2, and 4. Right? So it's f of 0 times delta x plus f of 2 times delta x plus f of 4 times delta x. Right? And this equals 4 times 0. Even though we're not simplifying, we should write this out. Oh, I shouldn't write f of 4 times 4 over 4 squared plus 3 times 2. Right. Maybe I'm going to condense this a little bit because I want to try to squeeze the right-hand endpoints in on this guy as well. And maybe I'll even take all of this and stick it over here. Okay, that's our answer. Right. Now, for right-hand endpoints, a lot of this is going to be the same, right? It's going to be... but it's going to be shifted to the right one, right? So instead of f of 0, f of 2, f of 4, it's going to be f of 2 delta x plus f of 4 delta x plus, and then this is the rightmost endpoint we didn't have before, f of 6 delta x, right? And rather, I should have moved this guy down here so I could say that the area approximately equals this. Right, which is going to be, well, can we be lazy? Of course we can be lazy. Plus, oh my goodness gracious, plus 4 times 6 over 6 squared plus 3 times 2. Needless to say, these are not such nice numbers, but there is a pattern to this, right? There's a method to this madness, right? We are just finding areas of rectangles. Height times width every single time. Next up, let's see, we've got this curve. Ooh, that's yucky. And if you think about it, delta x is also going to be yucky. It's going to be pi minus 0 over 5, or pi over 5. Not the nicest thing in the world. It doesn't matter. Our approach is exactly the same. We have the width, and using left endpoints, we have the height. And we just need to be a little more careful about what exactly, how exactly we determine the height. But just remember, we have 5 rectangles, so we should have 5 expressions. So the area is going to approximately equal, well, the first one is always the leftmost endpoint. It's f of 0, delta x. It's a delta, BT dubs. Plus, okay, well, now what's the next one going to be? Well, I'm just going to add pi over 5 to 0. And just plug that in. Multiply by delta x. Next one, well, I guess it'll be f of 2 pi over 5, because I'm just going to add pi over 5 to that. And then, well, I guess we could do this again. 3 pi over 5 delta x. And then we've got one more term. Okay. And then this is going to equal, well, you know, bunch of nonsense. And then it's times pi over 5 each time. Plus, right? 4 minus 5 times that, plus 7. Note that these are not even nice. Like, sine of pi over 5 is nothing nice, right? It's not something we know for the unit circle, right? You just keep doing this. I'm going to be really lazy just for space and time concerns and do plus dot, dot, dot. Do not do this on a homework or an exam or a quiz. But I'm just going to be like, okay, the last one's going to be 4 minus 5 times 4 pi over 5 plus 7 sine 4 pi over 5 times pi over 5, right? You see, this dot, dot, dot right here, I'll use blue for this guy. Dot, dot, dot was these two guys. Okay, so it would be a nice little exercise for you to fill that in. Okay, see what you get. And then the right hand is going to be the same thing, right? Well, shouldn't say the same thing, but a similar thing, right? But it's going to be that the area approximately equals, and again, it's going to be this but it's, right, we ignored the f of 0 times delta x, but it's going to be plus f of 5 pi over 5, which, by the way, equals pi, the right endpoint, times delta x. And so that's going to equal, again, I'm going to be a little bit lame, and let me get the freehand for this guy. A little bit lame and copy some stuff. Just a little bit of duplication over here. Ooh, get rid of that. Well, whoop, okay. Let's try that one more time. All right, we're going to be duplicating this guy. There we go, that's a little better. Right, this is going to equal this guy, and then it is plus the last one, which is 4 minus 5 pi over 5 plus 7 sine 5 pi over 5 times pi over 5. My goodness, okay. All right, last but not least, right? And another kind of icky one, right? Sorry for that typo. That should be that. Okay, so what we're going to say is, all right, delta x is going to equal 3 minus 0 over 4, which is 3/4. Not so lovely. But we have 4 rectangles. We can do this, right? So we're going to have that the area, or I should say using left-hand endpoints, the area is going to approximately equal, it's going to be f of, and we start at the leftmost endpoint, right? So it's going to be f of 0, delta x, plus f of, and we're just adding delta x each time. So f of 3/4, delta x, and then we're just going to add 3/4 again. So I'll just write 2 times 3/4. I mean, I could simplify, but I'm not going to. Whoop. And we're done, actually, right? That's 4. That's 4 terms, okay? And this is going to equal, again, square root of 0 cubed plus 1 times 3/4 plus square root of 3/4 cubed plus 1 times 3/4. The numbers are so gross. I can't keep track of them. This is something I had a hard time with when I first learned this stuff. You have to ignore the messiness of the numbers and focus on what we're actually doing, because these numbers will bog you down. All right, so that's our answer. And again, right hand, well, it'll be the same sort of thing. So right hand, same sort of thing, not the same thing exactly. Whoop. right hand, what's going to change? Well, we're going to get rid of this guy. Get rid of that guy. And we're going to add this guy, which is 4 times 3/4, which, by the way, is 3. Times 3/4. By the way, that's a 3, right? 3, okay. All right, and that's our answer. Okay, and that's all.